Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we are focusing on ISS 2026. We have covered the topic econometrics, which you can see in our previous lecture videos. We have started sampling techniques in which we have covered three major sampling techniques: simple random sampling, stratified random sampling, and systematic random sampling. And we in previous lecture we started ratio estimator. Today we'll continue with ratio estimator. In the last in the last lecture we discussed ratio estimator. What was the variance of ratio estimator? Ratio estimator is represented as y bar cap r. Now, since it is a biased estimator, its variance can also be written as mean sum of square of error. Mean sum of square of error. So this can also be written as MSE of y bar cap r. Right. So now, what was the formula that we did yesterday? Variance of ratio estimator was nothing but f by n into y bar square bracket sy square upon y bar square plus sx square upon x bar square minus 2 sxy upon x bar y bar. This was the formula that we did yesterday. So let us assume that let sy upon y bar be cy, sx upon x bar be cx, and we know that rho, which is the correlation coefficient between x and y, is nothing but sxy upon under root of sx square sy square. So from this equation we can say that sxy is nothing but rho sx sy xy, and hence we can write this variance equation as variance of mean variance of y bar ratio is f by n y bar square into sy upon y is cy square plus cx square minus 2. Now since sxy can be written as rho sx upon xy and sx upon x bar and sy upon y bar can be written as cx into cy, so it will be minus 2 rho cx into cy. This will be our formula for variance in the terms of C. Now we'll do the derivation of the comparison between the efficiency of ratio estimator and simple random sampling, which is more efficient estimator. Comparison between simple random sampling without replacement and ratio estimator. Now again writing this MSC of ratio estimator can be written as f by n into y bar square bracket cy square plus cx square minus 2 rho cx cy, right? And variance of simple random y bar, simple random sampling without replacement can be written as n minus n upon n n into s x square into sy square. This is the we are taking of y, so it will be into sy square. Now here we can say that we can take these terms aside, n upon n into capital N into dividing and multiply by y bar square, we will get this. Now from here we know that n minus n upon capital N is nothing but what? It is f. And sy upon y bar is nothing but cy. So substituting the values, we will get variance of y bar, simple random sampling without replacement, gives us f upon n into y bar square into cy square. So this is our equation number 1 and this is our equation number 2. Now we'll subtract both of them. So MSE of y bar ratio minus variance of y bar, simple random sampling without replacement, can be written as f by n upon y into y bar square can be taken as common. So we are left with cy square plus cx square minus 2 rho cx cy minus cy square. So cy square and cy square will get cancelled. So here we are left with f by n into y bar square bracket cx square minus 2 rho cx cy. Now all of this depends on this equation cx. So if cx, okay, we can take cx also common outside. So we'll be left with cx. So we'll be left with if cx minus 2 rho cy is if cx minus 2 rho cy is less than 0, then if cx minus 2 rho cy is equal to 0, then if it is greater than 0, then this will be greater than 0. Then of this, then simple random sampling without replacement is more efficient. Then ratio estimator. If it is less than 0, then simple random sampling without replacement is less efficient. Then ratio estimator. And if it is equals to 0, then both are equally efficient. Okay. So this is how we calculate the comparison between which is more efficient, simple random sampling or ratio estimator. Now moving on to the next topic, which is lower bound, or we can say bounds of ratio estimator. What are the bounds or what are the range of ratio estimator? So for this, let us consider covariance between R and x bar, where R, we know that R is nothing but y bar upon x bar. So covariance between this will be estimation of R x bar into minus estimation of R into estimation of x bar. Since this has been taken out from simple random sampling, so estimation of x bar will be capital X bar, and here R can be substituted y bar upon x bar into x bar minus estimation of x bar will be capital X bar, and this will be estimation of R. So this and this will get cancelled. We are left with estimation of y bar minus x bar into estimation of R. Now estimation of y bar is again capital Y bar minus x bar into estimation of R. Now dividing this whole equation with capital X bar. If we divide it by capital X bar, we will get upon X bar, Y bar upon X bar minus estimation of R. Now this term is nothing but R, capital R, we can say that. So our equation becomes estimation of R minus R is nothing but minus covariance between R and X bar upon X bar. Now we can say that rho, which is correlation coefficient between R and X bar, is nothing but sigma, is nothing but covariance between R and X bar upon sigma R into sigma X bar. So instead, in place of covariance, we can write it is nothing but minus rho sigma R sigma X bar upon X bar. Now we know that the range of rho, okay, we'll first put estimation of R minus R is written as bias of R, and this can be written as minus rho sigma R sigma X bar upon capital X bar. This rho can be taken as positive, and this sigma R can be written down here. So this will be our low upper bound. We know that rho goes from modulus of rho goes from 0 to 1. So this also will go from 0 to 1. So we are left with bias of R upon sigma R upon X bar. This can be written as like this. Okay, so this is the upper bound. So we can say that bias of R upon sigma R belongs to minus infinity till minus sigma X bar upon capital X bar. This is the bounds. The lower bound is minus infinity and the upper bound is minus sigma X bar upon X bar. This can be asked in the examination, and it has been asked a few times in the examination. You can check the PYQs relating to this, and the comparison is also very important. This was all for today's class. I hope you got what we have done today. If you have any doubts, you can ask us in the WhatsApp on the WhatsApp channel, or even in the comment section. Only relevant doubts will be answered. Keep on working hard and keep on consistently watching the videos and doing the work on yourself. We'll succeed in 2026 if you will be consistent and disciplined regarding the videos and your studies. All the best. Thank you.